Hi, welcome to Excel Class Hub. I'm Emmanuel Elizabeth Queen by name, and I'll be your chemistry teacher for today. So today I'll be talking about chemistry. So I'll be talking about laws of chemical combination. What are laws of chemical combination? These are fundamental principles that govern the behavior of matter and energy during chemical reactions. Chemical combination. So at the end of today's class, you should be able to explain and state the four laws of chemical combination. You should be able to balance chemical equation. You should be able to prove the verification of the four laws of chemical combinations. So let's move to the four laws of chemical combination. The first one is law of conservation of mass or matter. Two, law of definite proportion. Law of multiple proportion. And lastly, law of reciprocal proportion. So I'll pick it one after the other. The first one is the law of conservation of mass or matter. This law states that mass or matter can neither be created nor destroyed, but can form or can change from one form to another. This law was proposed by Antoine Lavoisier in the year 1789. Proposed by Antoine Lavoisier in year 1789. Now let's move to verification of this law. This law can be verified. It means that irrespective of the chemical reaction that has occurred, whatever mass that has been used cannot be destroyed or created. Now let's have an example of methane. Methane CH4 plus 2 moles of oxygen to give us carbon dioxide and water. The next thing is to balance the equation. On the left hand side, you have 1 mole of carbon and an atom of carbon. Same to the right hand side. So carbon is balanced. Then for hydrogen, you have 4 atoms of hydrogen, 1 mole of hydrogen on the left hand side. But on the right hand side, you just have 2 atoms of hydrogen. That means hydrogen is not balanced. What you need to do, you don't need to tamper with the atom that you have here, the number of atoms that we have here. All you just need to do is to balance it up with the number of moles that is here. Both number of moles can be multiplied with the number of atoms here to give us 4. Let's try 1. 1 times 2 is equal to 2. That means 1 cannot go. Let's go with 2. 2 times 2 to give us 4. So the right answer is 2. By the time we put 2 here, 2 times 2 will give us 4. On the left hand side, we have 4 atoms of hydrogen, and on the right hand side, we have 2 moles times 4 times 2 atoms of hydrogen to give us 4. Hydrogen is now balanced. Let's move to Mr. Oxygen. On the left hand side, we have 2 moles of oxygen and 2 atoms of oxygen to give us 4 oxygen in total on the left hand side. But on the right hand side, we have 1 mole of oxygen and 1 atom of oxygen in carbon dioxide plus 2 moles of oxygen and 1 atom of oxygen in water. That means carbon is or oxygen is not balanced. By the time we have 1 year and 1 year and 2 year, 1 plus 2 give us 3. That means it is not balanced. Then we have to add our 2 here. Adding 2 here, it has tampered with the oxygen, with the carbon that we have on the left hand side. So what we need to do is just to rephrase, check everything around again from the beginning and make sure that the equation is balanced. Let's see what we can do. 2 oxygen, 2 oxygen, 4, balanced. But here, 2 oxygen, 2 oxygen, 4, balanced. Carbon, 1 carbon, 2 carbon, unbalanced. Let's go for hydrogen. 4 atoms of hydrogen, 2 times 4 to give us 4 hydrogen. Hydrogen is also balanced. So what else can we do to make the equation balanced? Let's look around. Thank you. What should we do? What we should do is take these 2 out of here and add it to this place. From carbon monoxide to now carbon dioxide. By the time you look at it, 2 times 2 will give us 4. 2 atoms plus 2 moles will give us 4 oxygen. That means our oxygen is balanced. Matter can neither be created nor destroyed, but can change from one form to another, irrespective of the reactants we are using to give us a new product. The amount of mass of the reactant will be equivalent to the amount of mass of the product. For methane, we have 12 plus 1 times 4 to give us 12 plus 4, total of 16 grams of methane, plus 2. Remember, this 2 belongs to oxygen. If you have 2 elements combined together, whatever you have here belongs to the 2 of them. But since you have only Mr. Oxygen here, so we have our 2 outside, into bracket 16 times the 2 atoms of oxygen that we have here, which will give us 2 times 60 times 2 is 32. 2 times 32 will give us 64. So you have 64 grams, 16 grams of methane and 64 grams of oxygen to give us 80 grams of reactant in total. Let's move to the product side. We have carbon dioxide, 12 plus 16 times 2, which is equal to 12 plus 32, equals to 44 grams, plus water, 2 into brackets, hydrogen is 1 times 2, 1 times 2 plus 16. Excuse me. Okay, I'm just writing everything we've done before there. CH4, CH4, 2O2 to give us CO2 plus 2H2O. So we have the total mass of 12 plus 4, 16 grams, plus 2 into 16 times 2, 2 times 32, 64 grams. So we have the total of 80 grams here. And for this, we have 12 plus 16 times 2 to give us 12 plus 32 plus 4 grams plus 2 into brackets 1 times 2 plus 16 to give us 2 times 18 to give us 36 grams. 36 grams. Altogether, we have 80 grams. At the end of the day, we realize that the mass of the reactant is equal to the mass of the product. 80 grams of the reactant to give us 80 grams of the product, which clearly verify that mass or matter can neither be created nor destroyed, but can form or can change from one form to another. So let's move to the second law. Law of definite proportion. This law states that all pure substances contains the same element as combined in a simple proportion. I'll read for us again. This law states that all pure substances contains the same element as combined in a simple proportion, which says that if you have a drop of water and a glass of water, the same element that makes up a drop of water is the same element that makes up the drop of a glass of water. The only difference is that maybe in a drop of water you must have like H2O. H2O is the formula for water. Maybe in a drop of water, I may have like 0.005 mole. No, let me not use mole. 0.005 cl of water, and then in a glass, drop of water, glass of water. Then in a glass of water, I may actually have like 50 cl of water, which means that the same element hydrogen, okay, let's go. Water, 2 atoms of hydrogen to give us 2 atoms of hydrogen plus 1 atom. Okay, oxygen is actually diatomic. Let's say 2 moles and 2 atoms of hydrogen to give us with 2 moles of oxygen to give us 2 moles of water. At the end of the day, you realize that the equation is balanced. 2 times 2 will give us 4. 2 times 2 will give us 4. In this case, oxygen is a diatomic atom. It's just the atoms, 2 atoms of oxygen. But here it becomes 2 moles of oxygen, which makes the equation balanced. This is just telling us that the normal equation, the actual equation of water, which is H2O, element hydrogen and oxygen that brought about water, is the same element that is contained in a glass of water. And this theory was proposed by Joseph Proust in year 1755 to 1826. Irrespective of the quantity of water you're using, the same elements hydrogen and oxygen that combine to give us water, a drop is the same element hydrogen and oxygen that combines to give us a river of water, just that their quantity is different. Then the third law is the law of definite proportion. No, please, sorry. The law of multiple proportion. This law states that if two elements A and B to give more than a compound, if the fixed mass of A is the fixed mass of A and the various masses of B are in a simple whole ratio. Okay, I'll read again. This law states that if two elements A and B combine to give more than a compound, the fixed mass of A and the various masses of B are in a simple O ratio. This theory provides